Okay guys, here we go. The very first question. So what do we have? 1. A potter believes that 20% of pots break whilst being fired in a kiln. Pots are fired in batches of 25. A. Let X denote the number of broken pots in a batch. Okay, so initially from the statement, we can assume that this is a binomial distribution. Why? Because we're given the number of batches, which is 25, and we're given a probability of pots breaking, so an actual p-value, which is 20%. So instantly just say n is 25 and the probability is 20%, so 0.20. Okay, so far so good. Now, a batch is selected at random. Using a 10% significance level, we're going to get to the second. Find the critical region for a two-tailed test of the potter's belief. Now, you should state the probability in each tail of your critical region. Alright, so this isn't so bad. Now, all you have to do really is, given as two tails, this means that we should consider, let's say, a bell curve or straight line. Either is fine. Okay? This means that from each tail of the test, if we split this directly in half, we're looking at the edge. If it's 10%, we take half of 10%, which is 5 because it's two-tailed, and we allocate 5% in this region and 5% in this region. Now, if we assume that the middle is 50% because it's symmetrical, that means the first 5% is here, and the last 5% starts at 95. We only want probabilities that are less than 5% or greater than 95%, but you want to be as close as possible to 5. So what do we do? So well, all we do now is look at the binomial distribution table and just look at n equals 25 and p is 0.20 and just find the closest values. That is up to 5% and just above 95%. So let's do it. So here we go. So look at n equals, so initially always find n equals 25 and then p equals 0.20 and n equals 25. So we just scan down this column. So up to 5%, so in this case it needs to be no less than 0.05. So yep, this will be the tightest one. So this represents x is 1. So yeah, just to be clear, they also tell you more information. The tabular value is probability that the random variable x is less than or equal the points x. So this means here initially that this x is 1, so at this point it will be x greater than or equal 1, which equals 0.0274. So we're going to keep this down. And the second one, let's go up to 95%. Alright, here we go. So this is just above 9%, and the tabulated value is 8. So it would be probability x is less than or equal 8, which is 0.9532. Okay, so now all we have to do really just plot this down. So looking back in the curve, so this means that up to 8, so this notice how it says less than or equal. We want the greater than equal version, so we just basically 1 minus this term and just switch this to a 9, because this goes up to 8, we want 9 onwards. So let me just write this down. So up to here, this is probability x is less than or equal 1 with exact probability of 0.0274. At this point, this is probability x greater than or equal 9. Okay, the left hand side is less than or equal 8, and that is 1 minus this term, so 1 minus 0.9532 minus 0.9532, and that's it. You should be done then. Yep, and this small region represents exactly 0.0468. So ultimately we can say that the actual critical regions, which are the shaded part, lie between everything less than 1, so it will be the number of batches from 0 to 1. So we can 0 less than or equal x less than or equal 1, 2, actually I should just use the word and, because it's only the shade regions. My pen. And from here 9 onwards, so it'll be 9 less than or equal x less than or equal 25, because that's how many it goes up to. And I said this should be the end of solution. That's what we want. We want the values x that fit along this, that are less than 5%, or just over 95%, or the remainder 5%. Okay.